for the capacitors in combination, okay, for the parallel capacitors, okay, for letter A, capacitors connected in parallel. Given figure is this one. This one is positive, positive, negative, negative. Negative, negative, positive, positive, and then it's positive, positive, and we have negative, negative. Is the potential difference. That this one is your C1, capacitance, 1, 2, and 3. Now, this one is capacitors in parallel. Now, in finding for the voltage, if the voltage is placed across the terminal, this one is the voltage. Okay. We have your Q1 for the charge is equal to C1 V. And for Q2 here, you have Q2 is equal to C2 times the voltage. Then for Q3 is equal to C3 times the potential difference or the voltage. Then the total charge stored, you have your Q is equal to Q1 plus Q2 plus Q3. Hence, our Q, the charge is equal to equivalent capacitance times the voltage. Or that is equal to C1V plus C sub 2V plus C sub 3V. Then dividing out for the potential difference or for the voltage, we have equivalent capacitor is equal to C1 plus C2 plus C3. These are the formulas under the parallel. For letter B, now for the letter B, we have capacitor in series. Okay, now this one is the figure for the capacitors in series. We have the voltage, the capacitance, C sub 1, C sub 2, and C sub 3. Now, for the capacitors in series, for the charges, we have Q1 is equal to Q2 which is equal to Q3. Okay. And then the voltage R V1 is equal to Q1 over C1. While for V2, we have voltage at 2 is equal to Q2 over C sub 2. While for V3, that is equal to Q3 over C3. Now, the voltage across the equivalent capacitor, we have V is equal to V sub 1 plus V sub 2 plus V sub 3. Okay, which is equal now to charge over the equivalent capacitance. Now, with Q is equal to Q1, okay, with Q is equal to Q1 equal to Q2, which is also equal to Q3. Okay, we have Q over equivalent capacitance is equal to Q over C1 plus Q over C2 plus Q over C3, C sub 3. Okay, and dividing out by Q, we can say that your 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C sub 3. Okay, example. Example number 1. Okay, the parallel capacitor combination shown in figure below is connected across a 120 volts source. Determine the equivalent capacitance. And the charge on each capacitor. Okay, given figure, okay, we have 120 volts, C2, equivalent to 5 picofarad, and C1 is 2 picofarad. Okay, now for the equivalent capacitance, we have C equivalent is equal to C1 plus C2, which is equal to 5 plus 2. C equivalent is equal to 7 picofarad. Next, each capacitor now has a 120 volts potential difference. Now, Q1, we have Q1 is equal to C1 V1, which is equal to 2 picofarad. Therefore, that is 2 picofarad times the voltage of 120 volts. Okay, therefore, Q1 now is equal to 240 picocoulombs. Now, for Q2, we have Q2 is equal to C2 V2, where C2 is equal to 5 picofarad times V2, which is 120 volts. Q2 is equal to Q2 is equal to 600 picocoulombs. Now, the charge on the combination is Q1 plus Q2 plus Q1 plus Q2 is equal to 240 plus 600. 240 plus 600, which is equal to 840 picofarad. Okay. Where this one is for Q. Okay, Q is equal now to, which is also equal to equivalent C. Okay, we have C equivalent times the voltage, which is equal to C equivalent is 7 picofarad. 7 picofarad times the voltage of 120. Which is equal to is also equal to 840 picocoulombs. With the same answer. Okay, example 2. Find the equivalent capacitance of the combination shown in figure below. Okay, given figure is this one. First, you have to solve for the 8 microfarad and the 5 microfarad. Then it will become series to the 3 and 4 microfarad. Okay, first, the 8 and 5 microfarad is under the parallel. Okay, therefore, we have to get for the value of the 8 and 5 microfarad. Okay, like this one as C1, C1, C2, C3, and C4. Now, for C3 and C4, C3 and C4, therefore that is equal to, under the parallel, the formula is C3 plus C4, which is equal to 8 plus 5. Therefore, that is equal to 13 microfarad. Then, which in turn will become series with 3 and 4. Okay, therefore, under the series, we can say that from your capacitance or equivalent, we have 1 over C is equal to 1 over 3 plus 1 over 4 plus 1 over 13. Okay, this one is equal now to 103 over 156. Okay, therefore, this one would become C is equal now to 156 over 103. C now is equal to, okay, therefore, this one is equal to 1.51 microfarad. This one now is the equivalent capacitance.